yeah. Oh, if you're just joining us, you just missed it. Oh, well. Um, yeah, here's our calendar, the lunar calendar. Let's go on to this. So, oh, wait, this thing here. Let me remind you of something I showed you last time, and then I need to backpedal a little bit. Okay, so here's last time. Here we go. Let's go to the end here. Here we go, free, blah, blah, blah. Okay, so the cubic spline thing. And I was trying to program the cubic splines. I've done it in the past and thought I'll go start from scratch. Took out our book and I realized, whoa, it's different. Our book has a little difference. So I don't know if you've done the homework. I hope so. There was a couple, didn't I put a couple, 2 problems, 2 and 3? 2 and 3. So I guess the reason I'm bringing this up is that the equations that they use are different from my equations. I don't know if you noticed or if you just followed the book. If you followed the book, you're fine. You're doing great. So that's why I need to backpedal a little bit and correct myself. So this is the way I've always learned it, but I looked in the book and I guess that it looked a lot better to me, to be honest. But here, let me just back up, go to the beginning of this and show you the difference, and then we'll take a look at homework. So not to worry, we will take a look at the homework in just a sec. So cubic splines, just for a sec here, the big idea is that, yeah, ignore all that. Yeah, we're going to discard those and just go with cubics. So you're going to interpolate a function using a piecewise function instead of trying to do it. And the reason is this, that things are really ugly. But if we had a piecewise function, you'd just interpolate between those 2 points. And presumably, if we just interpolated between those 2 points, we'd get a much better picture, much better thing. So anyway, that's the big idea. Here's the difference right here. Yeah, this is the difference. Is that right? Just a minute, where is it? No, that's not the difference. Wait, let me find my difference. There's the difference. Okay, yeah, here's the difference. Right here. Let me show you the difference between what the book has and what I have. So I don't know. I think it's spread between 2 slides, but here's the difference. Is that this particular spline? Maybe it would be easier to show you on this picture here. Yeah, let's do this. Here, I'll show you the difference. Okay, so the difference has to do with the way that we're naming these things. And I know you'd think that nomenclature, what could be the big deal? But it's a big problem here. And even now, I'm not sure that I can remember. I think I know what the deal is. So here I will put up here what I was naming these. So the spline that went between the first 2 points, I was calling S sub 0. This spline I was calling S sub 1, and this one S sub 2. Now let me show you the way that the book named them. This one here, it called S sub 1. This one it called S sub 2. And this one it called S sub 3. Now at first glance you might think, well, who cares? You're just changing the index. It really doesn't matter. The problem is that in both cases, the subscript indicates which point the spline is sort of anchored at. And so the red ones, this red spline, S0, it uses X sub 0 as its sort of the center. If you want to think of it making a Taylor polynomial, you know, the center of the Taylor polynomial is that X0. Whereas the S1, even though it's the same spline, it's the same spot there, it uses X1. And so the equations are going to look, so in other words, when you get over here, it looks sort of similar. I mean, you're going to have something similar to this, but you know, my splines were looking sort of forward, and so mine, I was anchored here, and I'm like looking forward, whereas in the book, it's anchored over here and looking back. So the equations, though they look almost identical, are different enough that it was a big problem when I went to try to do the homework and try to compare with the book. So that's why I want to backpedal. I want to take a look at the homework carefully, and then hopefully we'll get this thing programmed on a week from today. So we'll get it in there. We'll get it coded. It's not terrible, but that's where I went wrong. So let's go back to the book just a sec. I'm gonna have to pull this up. Is my book here? Yes, here it is. And here is the problem that you did, supposedly. Here we go. Okay. So give me a sec here. Yeah, so none of the equations were wrong. It's just that if we're not careful, things get really ugly. Okay, so I also copied the actual book so we can refer to it. So here, I'll put these here. Okay, so write down the system of equations needed to solve in order to find the cubic spline through these 3 points. Let's see. I'm going to just crop this down so we don't have to look at problem 3. And then we're going to put the other one down here once I figure out how to extend this. There we go. Give me a sec. If we get to it, I don't know if we'll get to it. I just wanted to do penance because of the not lining up properly. And at first I thought, oh, it's not a big deal. And then I realized it's a big deal. So anyway, so here's the way I would suggest you do this. Let's see, we've got a bunch of stuff. I don't know, we got to label all, look at all those letters and numbers. Okay, so how about this? We'll do this. I'm going to make a little table. We always love tables in here, don't we? So we're going to have I, 0, 1, 2. And then we're going to have X sub I and Y sub I. So this is all pretty straightforward. And then we're going to have H sub I. There we go. So we're going to have to get this sorted out. So I'm not sure how you did this or if you finished it or if you attempted it or where you are, but thought that we could work through number 2, see how far we get, and then if we need to get started on number 3. And I know we did one of these with different numbers on Monday, but like I said, we were using a different focus in terms of the equations. So I wanted to back up and do it the right way, or at least the way that this book does it. And also, I guess also, when I looked at this refocusing, I actually thought it looked easier. Like the end game, the solution to this actually looked way better. So I'm curious to see if that's actually the case. So there's my y's and my x's, and I got my y's and my x's directly from the thing there. Now here's where I want to be careful because, like I said, I'm pretty sure that the focus is going to, like, here's what I mean by this, is that we're going to use these two to come up with the first spline, but I'm going to put those numbers in the column, in the row 1, and then I'm going to take the next set, these two, and come up with the second spline. So let's just double check to make sure that we're going to do this correctly. Okay, we've got these points. Oh yeah, this is the textbook. So here's the critical part that I noticed that I messed up. So notice that their equation here looks suspiciously similar to our equation, or the one that I had. Here's the crucial point where I realized I had done something different from the book, is right there. You'll notice that S1, spline 1, is going to be for the gap between x0 and x1, whereas I had spline 0 between x0 and x1, which once again, it doesn't seem like that should make a big deal, but it does. It makes a huge deal. So the equation looks, this up here looks the same. It's not different. Let's see if there's anything else. We've got the conditions. Okay, we know about those. Just to remind you though, we want the spline to match up at the endpoints. That is, the function value should match the spline. So the spline is just a cubic, it's just a polynomial. So it's like you've got these two dots. This is x0, up here is x1. And so all this is saying right here is that whatever you end up with, it should match those 2 points. So that's part 1. Part 2 just means that when I get to the next spline, so I've got my next point over here somewhere, then I better make sure that the slopes match. So I don't want to do this. So notice that that's bad because I've got a corner there. So the slopes are going to match. And not only that, the second derivative matches, which is harder to see because how can you see concavity? But whatever. Yeah, so the slopes and second derivatives match at that point. And then there's this, there were several different endpoint conditions, but the first one is the one that we want, which is called the free cubic spline, just because that's the easiest one to deal with. Well, we could deal with the clamped version another time. Okay, so that's all taken care of. I think I'm pretty happy with that stuff. Now let's go down here. Oh, the H's. That's what I wanted to make sure. Sorry, I got to go back to the book. I thought I copied everything that I needed, but I got to go grab the H's just to make sure. Whoa, where'd it go? Okay, just a minute. Oh, yeah, this is where I realized I was, in this so-called octave code, whatever this is, I was translating it, or I was, translating it to Python, and I realized somewhere here, I forget where I was, that it was not the same as what my formulas were. Okay, so I just want to make sure that everything's kosher, that we're doing it right. So where are my H's defined? They aren't defined here, and I just copied this stuff. Just a minute. H. You would think, oh, here it is. There. Okay. Oh, hold on a minute. That doesn't make any sense. Doesn't that mean that the H's are backwards? They'll all be negative? Is that really what they want us to do? Surely not. That feels wrong. No. I think that they're, super irritating. This makes me nervous. Why is that negative? Okay, I'm going to just make it positive, and then if we need, oh, I know what I can do. Just a minute. Let's see. I think that's backwards. There's a typo. Let me double check though. No, weird. Why? It's like that. That's so weird. Okay, they're negative. That doesn't make any sense, but I'm going to go with, okay, we're going to stick with the book. Okay, I'm glad I checked because I just wanted to I was more worried about the subscript, making sure my subscript is right, but hey, if they want to make me to make it negative, that's fine. Okay, so I'm going to put it right here. So this will be -1 and this will be -1. So in particular, the top -1 is going to be 0 because it said take the previous x value minus this x value. That's what it said. And I thought maybe it was a typo, but it's not. Or at least, I don't know, we're going to find out. So this minus this. So now I'm just as lost as you guys. So just so you know, we're in this together. But I think we can do this. We're not too far. There's not a lot that we have to do this because it's just these 3 points. Okay, so there's my H's. Okay, now for the hard part is we need to set up equations to compute the C's. That's really what it's asking for here is what system of equations do you need to solve? And honestly, I don't know why they say don't attempt to solve this. It's three unknowns. I mean, what's the big deal? So, well, we'll see. If it's not hard, I want to solve it. Okay, so let's do that's the next step. You see, here's why that's the next step is because they have this series of equations here that are all the D's in terms of the C's. And then you have this series of equation which has the B's in terms of the C's. And so the main thing that we have to figure out is how do we compute the C's? So that's going to be down here somewhere. Oh, sorry, that's B1. Yeah, we'll get to that in a sec. Here it is. Here is the C's. Sorry, just double checking. That is one of them. Where's the rest of them? Come on. Final equation. Well, I'll write that down. Okay, let me just write this one down, this 5.2.11. Now let's see if we can do that. So give me a sec here. I want to grab this. I'm going to copy this. Copy. Copy. How do I copy? Oh, I duplicated. Hold on a minute. It's going to be mildly annoying. So I need to crop 5.211. There it is. There we go. Okay. Let's see what happens. Let's see if we can work this out. So there should be two more equations, but I don't know. Okay, so 2 times h1. So let's do this. h1 plus h2 times c1 plus h2 times c2 is 3 times this divided difference. By the way, these are both, I don't know if you recognize this, these are both divided differences. They're just slopes. So this is you're basically doing this difference divided by that difference. So those are just slopes. Okay, I see what they've done. I don't know if you, now I see why their h's are negative, is because they've also switched the tops of their divided differences. Just, I don't, well, I've made my bed. I'm gonna have to lie down in it. Okay, so let's go ahead and do this. So first one is gonna be 13 minus 9 is, let's see, wait, negative 13, all these negatives. Okay, negative 9 minus negative 13 is positive 4 over negative 1. And then the next one, negative 13 minus negative 29, which is positive 16 over 1, negative 1. All right, there we go. Okay, let me just clean this up. Or C1 minus C2, 3 times 4, 16, 12. 3 times 12, 36. All right, well, that's only one equation. I need two more equations. Yeah, I think that's the deal. Because this is a free cubic spline, where is it? It's down here somewhere. I don't see it. Yeah, because it's a free cubic spline, the yeah, you get that. Why is it so hard? Maybe I made a mistake choosing to do this topic at the end. Yeah, C0 equals 0 and C2 equals 0. I think that's the deal with the so the first and last ones are 0 because of the second derivative. And this has to do with the, oh, and yeah, we don't even have a C0. Well, that's okay. So C2 is equal to 0. So that means that C1 is negative 9. All right. Well, let's put these in the columns here. So we've got C2 is 0. Let's barrel on ahead and see what happens. Negative 9 and 0. I guess this is 0. We could put it in there. And then from here, we can just compute the rest of these. The b's, is that what's next? Yeah, here's the formula for the b's. Wait, isn't there a better one down here? Oh, no, that's the formula for the first and the last b. So here's the general formula. So the b's, you have this general formula, which, you know, not that bad. I see why they probably said just set up the equations. Oh yeah, here's the C in is equal to 0. There it is. So yeah, so that wasn't too bad. I mean, I guess we can keep going and get our B's. Why don't I do that? Yeah, let's get the B's and then we'll be happy maybe not happy. So it says B1. Let's use this one here. is y, so you got the divided difference, the first slope, minus 2/3 of c1 times h1. Okay, let's see if I can do that. Let's see. Oh, come on. Sorry, my notability keeps moving around. Okay, so we have y0 minus y1 over h1. This is going to be b1 minus, what was it, 2/3? Yeah, 2/3 of c1 times h1. Okay, where did that thing go? There it is. Minus 2/3 c1 h1. And so in this case, let's see, this is going to be 4 over -1, 2/3. C1 was 9, -9, times H1, which was -1. So this is going to be -4. Is that minus triple negative 6? -10. So that gives me B1, BI. And now I just need DI. And then I can write down at least one of the polynomials. Still don't know how I'm supposed to get the second one, but got one of them at least. So the D's, where's the D's? The D's were simple, weren't they? Yeah, they're right here. So here's the D's. So it's just the difference in the C's over the H's. So it's another divided difference. 1/3 of the divided difference with the C's and the H's. Let me do this. So 1/3 of the divided difference of this and this. Oh, no. It's this divided by this. So 1/3 of that. So DI is going to be 1/3 of -9 minus 0 over -1. Hope that's right. So that's going to be 3. Okay, well, at least I can write one of these down. So let me write down one of the polynomials, one of the splines. So this is this spline right here. I have all the information for it. So at least we can do that. And then hopefully I can pick up the pieces for next week and get the actual code figured out. So here's what the code looks like. Oh, the one thing I don't have here is the A's. The A's are all here. There, those are the A's right there. Okay, so we're going to do spline 1 is going to be -13 minus 10 times x minus 1. Give me a sec. I'm curious to see if this actually works. I will be super depressed if it doesn't. X minus 1 squared, and then plus 3 times x minus 1 cubed. So just so that you can navigate this, if you're like, where is all this coming from? So this is A1, this is B1, this is C1, and this one is D1. Okay, so how am I going to see if this actually works? Well, I guess I really can't see unless I get the second spline, but I can do this. I can see if this matches up with this point. Because here's the deal, is that polynomial, that cubic, it should go through both of these points, and it should have the properties with the slopes and all this other stuff. So at the risk of finding out that I failed, I'm going to plug x equals 0 into this spline just to see what happens. So S1 evaluated at 0. Let's see, this is going to be plus 10, minus 9, minus 3. Not quite. Ooh, I'll bet you I messed up here. Here, let's just pretend that this, I messed up my, there. Let's pretend that this is supposed to be negative. I'm pretty sure I messed up. I must have mixed something up there. Is it supposed to be negative? Just a minute. Which one was that? That's the D. That's this one. Sorry, it keeps moving around. Oh yeah, it should be 0 minus -9. I see. Yeah, it should be negative. That makes it so much better. 0 minus -9. That's, I believe that's, is that what you're going to say? Okay, yeah. Okay, so then that's +3. And sure enough, happiness works out. It is the same. At the risk of being even worse wrong, which I don't want to do, but I could do the second derivative evaluated at 0. And when I do the second derivative evaluated at 0, it better be 0. So, because that's that end point condition. And then if I had this other spline, which I guess I just was either too lazy or just didn't want to compute, I could check where they intersect, like where they touch, to make sure that the slopes match up and the second derivatives match up, and then check the other endpoint. But let's just believe, let's see, can we believe that it will be the case? Let's see, that's going to be second derivative of this. Oh yeah, actually we can be for sure. That should be a plus. Oh wait, no, that's a minus. Second derivative. Because the second derivative of this one is going to be -18. The second derivative, oh yeah, that'll be good, because the second derivative of this is -18x minus 1. Okay, so yeah, the second derivative at 0 is, it's 0. So that's happy. So at least we checked some of the conditions. So I feel pretty good about this, and I feel reasonably good. I'm a little queasy, to be honest, but a little bit good about the fact that, where is it? This is what made me encouraged when I read this. It's right. Oh, I don't see it now. It was in the equations, the C sub I equations, wherever they were. All I see is C1, C2. Maybe it's here. Yeah, here's the C sub I equations. Yeah, that is not as encouraging as I first thought. Yeah, you still have 3. See, the problem here is that you have this big matrix that it's got a bunch of rows, and each row has 3 entries, and just going to be a lot of work. So, but it's not insurmountable. We can do it. All right, so I just wanted to get through that. Like I said, I started the Python. I didn't finish it because I got scared that I was doing something wrong. So I wanted to make sure that we got it right. Are there other questions about the homework? Did you do the homework? Did you do anything? Or is it okay? Sort of okay? I mean, basically, I kind of stumbled through that piece of it, setting up these equations. There's really only one equation. The second one, there it is. This one, similar deal. You could just figure out your H's. Yeah, it's really bothersome to me that the H's are negative, but I can deal with it. So any other issues, questions? All right, well, yeah, I didn't want to start the programming if I didn't have a good handle on the cubic splines. So next week we'll get the cubic splines in there. I'll also have a practice test for the final, because I know that's important. So I'll have that ready before Wednesday so that you can have it to look at it, because finals is coming right up. Look at this, we have extra time if you need to go to get an extra bucket of tater tots or whatever they have. It is tater tot day. I know, I had a bowl of them. So, oh, we should stop the recording in case you want to chat. Or if you just want to have an extended time.